So, welcome everybody. I got failed in this, I apologize for the delay. I got failed by the public transport while coming with the, flat in Rome, and because it rains a little. But, we will now try to catch up. There will be two topics in this lesson. The first one is called robust estimators, and we will be dealing with the handling of outliers in the measurement. What is an outlier? Is a data association that shouldn't be there, basically, or is a sudden spike in the error which is not well captured by the model. Okay? Now we will start this episode, the first time of this episode, by recapping what we have seen. So, at the very end, what we are interested in when approaching a problem with Gauss-Newton is to minimize a function f, which is the sum of many scalar errors denoted in this slide with E with I. I finish the slide and then you. Then we also have seen that the scalar errors are, by embedding some special assumption into our system, which is the Gaussian error function, these scalar errors are the result of the outer product of the error vector, which is the difference between the prediction and the measurement, which is scaled by an information matrix omega that modulates the components of the error term. This results in some sort of Mahalanobis distance. Now, please, in the reminder of the course, I will always refer to this norm, because in fact it's a norm, because it's a scalar that you calculate out of a vector, with the word omega norm, right? The omega norm of a vector v is defined this way. Omega, this is the omega, is defined this way. Okay? It's like v transpose omega v. Clearly, if omega is the identity, the omega norm is nothing else. The L2 omega norm is nothing else than the squared norm of the vector. Okay? Because it will be v times v transpose. Similarly, what we do in the end in Gauss-Newton is minimize the omega norm, so the squared norm of the sum of the error vectors.
Yes. My doubt is with the notation. So when I characterize the program that you talk about, we have E, the error, right, is a function. But like that, it looks like that you have an array of functions, right? We have